So now, after we just did the introduction to operons in general, we're going to look at one specific operon in bacteria called the TRP operon. The TRP operon, okay, codes for genes, okay, that code for proteins, really enzymes, okay, like they're enzymes, but they also are protein, that make tryptophan, okay. So if you think about the question, when would you want these genes to be off, okay, like when would you not need these genes? And you wouldn't need these genes to be on, okay, when you have enough tryptophan. Like if you have enough tryptophan, you don't need the proteins that make it, okay. But you would want these genes to be on, okay, when you need to make tryptophan or you're lacking tryptophan, okay. It's important that you like hold on to that idea, okay. That idea will help you with this, okay. The fact that you want these genes to be on, okay, when there's no tryptophan, so you can make the proteins that make tryptophan. Okay. The TRP operon is said to be a repressible operon. The reason why it's repress means to stop. Okay, so if I was like going to stop someone from complaining, you would repress them from complaining. Okay. Now, things that are repressible operons are operons that start as being on and need to be turned off. So if we take a look in its normal situation, this is the TRP operon. If you take, these are the genes here that code for the proteins that will make tryptophan. In its natural situation, it's on. The RNA polymerase is on the promoter, and it can transcribe the genes into mRNA, and that mRNA will make protein. Okay, we're going to look at the TRP operon in two situations. Okay, when TRP is present, and when TRP is not present. So in the first situation, okay, we have tryptophan present. Because tryptophan is present, we do not need to make the tryptophan building enzymes. Right? We don't need them. We have tryptophan. We don't need these enzymes to be made. It's pointless. Why do we need to make these enzymes and we have tryptophan? We need them. So watch the steps that happen. Okay? Because you have a lot of tryptophan and you don't want to make the proteins that make it. Okay? Tryptophan binds to the repressor protein, okay, and activates it. So here we have the repressor protein, okay, and there's lots of tryptophan, TRP is present, and it binds to the repressor protein and activates it, okay. When the repressor protein, okay, is active, it then can bind to the operator. This should say operator, not operate. Ms. Russo's lame, okay, and because, okay, this is at the operator, it blocks transcription. And RNA polymerase is blocked from making the mRNA. As a result, the gene is off, okay, and no RNA will be made. Okay, it's important that you realize these steps, okay, and you're able to say that when TRP is present, it binds to the repressor protein and activates it. When the repressor protein is active, it binds to the operator and blocks transcription, or it blocks RNA polymerase, which blocks transcription. Okay, now we're going to look at the reverse case. The other thing I guess is important is tryptophan is an allosteric regulator of the transcription repressor protein. When tryptophan binds to the repressor protein, it changes its shape. But instead of actually deactivating it like you think of as an inhibitor, when tryptophan binds to the repressor protein, it activates it and then allows it to bind to the operator, which allows it to block transcription. We're now going to look at the second case that could be. Okay, when tryptophan is absent. So, when tryptophan is not present, there is nothing to activate the repressor protein. As a result, the repressor protein can't bind to the operator. Okay, and because the repressor protein can't bind to the operator, okay, RNA polymerase is free to transcribe the genes, and the gene is on. Okay, so let's look at the text. So, step 1, tryptophan is not present, so it can't bind to the repressor protein, and as a result, the repressor protein is not active. As a result, RNA polymerase can bind to the promoter, and when it can bind to the promoter and it's not blocked, remember, it would normally be here, the repressor protein would normally be here if it's active. Because the RNA polymerase is not blocked, okay, it can transcribe the mRNA, and then the mRNA will be turned into protein. And then those proteins will make tryptophan. And once they make tryptophan, then we'll go back to this place, to this slide, where now tryptophan is present, and then it will block transcription. So let's talk about what you gotta do for homework. For homework, you have to do three things. You have to answer the guided questions for the first video and the guided questions for the second video. And I also want you to fill out this chart. Okay, if you can fill out this chart, you understand the trip operon. Alright? Tomorrow, in class, we're going to learn about the lack operon, which confuses things a little bit. Alright? But I'll see you guys tomorrow. I also suggest, and you can choose to listen to me or not, that you don't wait till Wednesday morning to watch these videos. Not a good thing. Okay? I would do them tonight. Don't wait till Wednesday morning to do the guided questions. Please do them tonight. Alright. I'll see you guys tomorrow.